Welcome back, everyone. So in the last few lessons, we've learned about making some performance optimizations. We learned how to use React Lazy in order to lazy load our components into our application. We learned how to handle code splitting at the route level by using these lazy loaded components with React Router and then wrapping them in React Suspense so that we always had a fallback UI in case these components did not fully render or get retrieved from the backend server by the time we needed them. We also learned how to build error boundary components in order to provide yet another piece of fallback UI in case anything goes wrong inside of the child components of the error boundary components that we created. So we've learned a lot already about improving the user experience of our application already. And the main thing of performance to remember is that we only need to do these things in order to improve the end user experience. Optimizations for the sake of optimizations is really an empty goal in itself. So this harks back to what I mentioned in the first lesson of this section, which is that you must measure and you must consider the trade-offs when making optimizations, and you only want to make performance improvements when you hit a problem. Now, in this section, I'm going to actually teach you some React component level optimizations, and I really want you to think about this because we're going to explore some examples as to why you don't want to get too eager or too aggressive with over optimizations. You really want to take a step back and consider why you're making this optimization in the first place, and you want to think about the overall context of what it is that you're improving. So, let's get right to it. Now, what I want to do is actually go back to our life cycles method lesson and really rethink about this one specific life cycle method, which was should component update. If we go back to the code inside of our life cycles component, if you remember, there was this life cycle method that we had access to on our class components called should component update, which received the next props and the next state that was coming into a component, a class component to be particular specific, where we would be able to compare the next props and the next state against the current props and the current state to decide whether or not we wanted to return true or false, which would then dictate whether or not this component would re-render. This was done in order to save us on unnecessary re-renders if the props were going to come in the same. Now, why would this be important? Well, this is literally a performance optimization because saving ourselves on re-renders is most likely the biggest optimization we can generally do when it comes to the speed and performance of a component. But us manually writing this is great if we need this level of granularity, but there's an easier way for us to do this, and the way we do it is to use two different types of new functions and classes that we get from React and replace our existing React.component or our existing functional components. So I'll show you what those are in this lesson. Now, what I've done is I've created this person component just to demonstrate to us rendering cycles. So we have this person that is a functional component. It takes a person object as a prop, and it simply returns a div with the person name and the person age, and it logs rendering whenever it gets rendered. Inside of our app.js, we have our app component. We import in this person component I just wrote, and what we do is we have a count on the state, and then we have inside of our component simply a button that whenever you click will increase the count, but also we have the button count displayed. Now, above this component, I'm going to put our new person component. And what I'm going to do is I'm going to pass in the person property by passing an object inside of the render here manually, where name goes to Jack and age goes to 22. Now, because I'm inline defining this object, you will see something interesting whenever we actually end up re-rendering this component. Now, I want you to take a second and think. How many times do you think our person component is going to end up calling rendering? If what you guessed was more than once, then you would be correct. So when our application mounted for the first time, we mounted our person component and rendering was logged. But you'll see that every time I increase this button count, that component is actually getting re-rendered. And the reason for this is because whenever setState gets called inside of our component, our app component, we end up re-rendering everything, which means that a new person is going passed into the person component. Now, you might think if I move this object into the state, would this actually mean that I save myself on some renders? Well, this actually isn't going to work either. So if we destructure person and we move it onto the state, we'll notice that when we pass it in, whenever we increase the count, we're still re-rendering. And the reason for this is because this component is a functional component. And a functional component will always re-render whenever the parent re-renders, because the functional component simply does not know. It's essentially being called and invoked every time on render to provide us with a new component. So that's one thing to remember. The next thing is that how would we actually save ourselves on these re-renders? Well, here's the way that we can check. So the first thing what we want to do is see how much time it actually costs us to re-render this person. And what we can do is actually download in our React DevTools if you have not already. So React DevTools is an extension that the web browser provides. And here you'll see that we actually have it already installed on my Chrome browser. If you don't have it, just simply use the link that I provided and then add it to your Chrome. Once you've added it to your Chrome browser, you're able to access it by going to this React button inside of the top bar that lets you switch between different views inside of your DevTools. Now, inside of here, we'll find that we have access to our application tree, where we have the right name associated to our components instead of the actual rendered elements we see when we typically go to our elements. So if we had divs, we would see them as divs. If we had p tags, whatever. But inside of the React profiler here, we actually see the right name for the right components. But instead of focusing on that, we want to look at the profiler, because the profiler will tell us how many times components were rendered and how much time it took for them to actually get placed on the page. So if I hit this record button and I start clicking my button, it's tracking all of them. And when I stop it, you'll see here what looks like a timeline. Now, this timeline actually represents what it is that these components took in order to render. So let's look at our person component, for example. So we know that our app component, of course, got re-rendered, but so did our person component. If we look at it, we'll see up here in this bar, it actually shows us these elements. Every time you click it, it advances through that chain, and it tells us how many renders actually happened here in the total number of renders. And every time it rendered, what were the props that got passed into a person component. The interesting thing is if you hit this icon here, it actually tells you the total amount of time each re-render took. So the initial mount, of course, took longer than the end of subsequent re-renders, because the initial mount, as I mentioned, mounting is the most expensive because it's a DOM required change. Whereas re-rendering simply changes the values inside of the actual node, but it doesn't have to create a new DOM node. Whereas here you'll see that these are faster to re-render, but we still had to spend half a millisecond every time we increase the button count. But despite that fact, our props never changed. So we actually are costing our application quite a bit on these re-renders. Now, how do we actually improve this? Well, this is where we can actually improve our person component by using React Memo. React Memo is a way for us to memoize this component so that the component does not re-render if the props values do not change. Now, what do I mean by this? Well, just like with our should component update lifecycle method on our actual class components, React Memo does the exact same thing as implementing a shallow comparison that should component update does for our class component. And in a similar way, using React.memo on our functional components allows our new component to check the old props against the new props to see if the value has changed. Now, what this means is that in order for us to use it, we wrap our component with React.memo like a higher order component, which will memoize the actual component. Very similar to reselect when we memoize our selectors. The only difference is that it checks to make sure that the actual object values have not changed at the root level, which is a shallow comparison. We'll talk more about the shallow comparison a little later. Let's actually first see what happens. So now if we look at our app.js, we're still passing in our person from our state. And now we'll see that whenever we actually increase the count, we're not re-rendering anymore. In fact, to prove it, we can go back to our React profiler. We can refresh our page. And now if we start profiling, and I start increasing the count here, we'll see that our person simply got rendered the one time, and it never rendered any more times during the recorded time, other than the initial mount. Now, the initial mount occurred before we actually started our profiler, therefore we don't see any of those renders because none of them exist. Our component simply mounted the first time to render, and that was it. So we can see how that actually helps us out because now we have improved the actual performance of our component. But the question is, how much did it improve it by? Well, in order for us to see that time, we do need to actually profile the initial mount. So we can do that by making a slight change to our code here. So I'll simply add a show person toggle value of initially false and make sure that we set show person here and dynamically decide whether or not to show this person component based on our state value of show person. And then I'm going to make a new button that says toggle person. And all it does is it sets the state where show person is equal to the opposite value. So nothing new here. I'm simply just toggling this value. Now what happens is that we don't initially see our person. I'm going to start recording our profiler. I'm going to toggle it on, and then I'm going to click increase count, stop it, and now we'll see that we've actually got our initial render time, which is 1.5 milliseconds. So that's how long it took for our component to mount, our person component. Now, however, if I remove this React memo, how much time do you think it actually takes to render the person the first time? Not the subsequent times, but just the first time. If we start profiling it again, and we toggle person, and we stop, we see that the initial mount was 1.3 milliseconds, which is faster than when we used our React memo. The reason for this is because the initial memoization of our component takes longer than just simply passing the component itself. So this is a thing you gotta remember, is that everything comes with a cost. Every optimization that we make does come with a cost, even implementing should component update, because this means that our class component has a new lifecycle method that it has to run every time props or state changes. This is important because if you have components that don't take props, then there's no need to actually memoize them. In fact, if you have components that don't modify state or don't need the lifecycle methods or rarely change their props at all, then there's also no reason to memoize them. So this is a thing to remember. You always want to be measuring to see whether or not your components are actually performing faster in the grand scheme of things. Because if we start memoizing all of our components without thinking about the context in which they are used, we'll actually end up with a slower application as a whole. So the alternative to using React Memo for a class component is React.pure component. And this is essentially the same thing as implementing a should component update method where we're able to compare next props to props and next state to state. It just simply does it for you under the hood. so you don't have to implement it yourself. Very similar to our React Memo, except of course React Memo is for functional components because they don't have local state. So these are just things to keep in mind with these actual new versions of instantiating components that we can use to optimize our components. But again, context is the most important thing. In the next lesson, we're going to talk about the shallow comparison and more considerations about how that might affect our application. So we'll talk about that in the next lesson.